Here we are required to solve for x. In this equation, it says 20 raised up to the 5x minus 8 is equal to 7. Solve for x. X, as we noticed, is in the position of being the exponent, so therefore we have to apply the power rule, okay, of logarithms to help us solve for x. Whenever you want to solve for x and x is in the position of the exponent, then logarithms comes to the rescue. Okay. Right. So what we are going to do now, we are going to demonstrate how we can apply the power rule of logarithms to solve for x, whereby x here is part of the exponent. Okay. Very important rule for logarithms. It states that whenever you find the logarithm of a value, for example, and that value is raised to a certain exponent, then this is equal, it's the same as that exponent multiplying to the logarithm of that value. Now, in order to apply the power rule, that value must be by itself basically on one side of the equation. Okay, that base alone raised to the power must be present on the you know, on that side of the equation. There must not be anything there with it. As we can see, there's a negative 8, so we have to cancel out the negative 8 in order to proceed. Okay, in order to apply the logs, we have to cancel out the negative 8. Okay, and to cancel out the negative 8, we'll add 8 on both sides. Okay. Yeah. So that's what we're going to do now. Yeah, so okay, just a minute. So as we said, we're going to add 8 on both sides to cancel out 8 in order to apply the logarithms. We cannot apply the logarithm yet because 20 raised to the 5x alone must be on one side of the equation. It must be by itself on one side of the equation. So we must cancel out the negative 8 there. Okay. So then we have 7 plus 8 is 15. Now we can apply the power rule. Okay. Now the power rule can be applied. We're going to just write, you can write ln or log. If you write ln, then you are using logarithm to the base of e. Okay. If you write just log by itself, then you are using logarithm to the base of 10. Okay. And that will suffice to apply the power rule to bring down 5x, if you want to put it that way, to multiply, okay, so that we can proceed to solve for x. So we're going to apply the power rule now, because 20 raised to the 5x is by itself alone on the left side of the equation. Okay. So we're going to use a log in this one, log to the base of 10. So log of 20 raised to the 5x is equal to log of 15. What you do on the left, you have to do on the right. And by applying the log, this allows for the application of the rule. So 5x can be written in front of the L. Okay? And this allows now for the division of both 5 and the 20 and the log of 20. So that they can both be cancelled out to get x by itself. Again, what you do on the left, you must do on the right. Of the 5 log 20 cancels out. And what we basically have now is log. Oh, I write it long. I wonder if I can write it. Well, here the function is. See, it's not in italics when I type it. Oh, so you can be typed here. So log, and just press tab, open bracket, log of 15, close bracket, divided by 5 times log of 20. All right, and that should give us the value of x in this example, which is 0.306. Okay. If you want, you can even substitute, just to prove your answer, substitute 0.306 in the original equation, okay, to see what happens. If we get 7, let's see if we get 7, just for proof. As 20 raised up to the 5 times, here's what we got, 0.306. So let's just see if this gives us 7. Enter. Okay, so I get 89. So something is wrong somewhere. Let's see what is wrong. 20 raised up to the 5x, we minus 8. We add 8 on both sides, 15. Log of 15, 5 log of 20. Let's see if log of 15 divided by 5 times log of 20. Okay, so it appears that my typing log in this calculator is null and void. Okay, so it's a good thing that I tested the solution. So it appears that the solution is 0.180.1. Let us just prove the answer now. Come back here. Come on. Right? So let's substitute in that power here. Five times 0.181 minus 8. I wonder if this will give 7. Yes, 7.0. Okay. 7.0 Well, I put 0.1 it 1. So if I put the entire, okay, let me just take this out and put the entire solution, then we should get, let's see, because I put 0.81, so I round up. That's why I put a little bit above 6.999. Okay, so you can prove your answer to make sure. So it's a good thing that we proved our answer. So typing LOG in this calculator does not work. We have to actually click on the LOG function. All right. So the key point there, before you apply log, make sure that the base and the power is by itself on one side of the equation. And it doesn't matter what is on the other side, just once the base and the x in the power alone, and then you can apply logarithms. Log to the base of 10 or log to the base of e.